Welcome to my wireless communication project. My name is Hamza Khadim Heza and my ID is 2017-01064. In this presentation, I'm going to discuss what are the objectives and purposes of this project. Second, I will illustrate the network planning and designing including coverage parameters and indoor network design. Third, I will show the network topology using Omnet++ software. And then for implementation, I will discuss the network design, traffic design, and quality of service classes. Moving to the network evaluation, I will demonstrate the performance indicators, quality of service and non-quality of service scenarios, project summary, and what are the future recommendations from my side, and finally the discussion part. In the beginning, MobiServe company needs to deploy 6th generation wireless local area network using IEEE 802.11ax infrastructure across Bahrain, and their aim is to provide Bahrain residents with quality services in several areas such as governance, education, and health. By the collaboration between me as a telecom engineer and MobiServe, I I was responsible to implement the 6th generation local networks with their designated requirements and provide them with a detailed report about the implementation. In the upcoming slides, I will include access point planning, parameters used to implement 802.11ax technology, and evaluating the performance of the technology used using quality of service and non-quality of service within indoor environment. This slide indicates the network planning and designing. The design on your right hand illustrates the blueprint of indoor propagation. In this house design, I have located 3 access points to cover the whole network with minimum interference possible to give the user the best experience while connecting to the access point. Moreover, the parameters used in this design were selected to provide the best coverage across network, and the parameters are frequency of 2.4 GHz, a channel bandwidth of 20 MHz in each router, then the modulation used in circled range is 64 quadrant amplitude modulation, and by using an appropriate equation, the transmission power of the modulation was 90.9163 decibels. And regarding the antennas, I have used MU-MIMO 4x4. Moving to network topology justification. As MobiServe requested, I have designed the network based on indoor environment. Therefore, the locations of access point were chosen to cover the whole network and keep the users connected anywhere they go within the network. Furthermore, the indoor environment has multiple characteristics. It supports both frequencies 4 and 2.4 GHz and it has small coverage distances. Then it will provide high flexibility in installation process, but the biggest challenge is the materials and walls of the building since it affects on the network traffic and resulting with path loss. Additionally, in my indoor environment, I have used 2.4 GHz because it covers larger areas and shows good functionality when providing internet access through walls. Furthermore, this slide indicates the implementation of the network design using Omnet++ software. This network model includes 3 nodes: client, server, and access point. The source of the traffic comes from client side, and the server is the destination of this traffic. Moreover, the access point is the mediator between both client and server, and to module this network, I have used INET framework modules. Going to the traffic design, the simulation consists of 4 services. First, the background traffic on port 21, for example, the FTP. Second one is the best effort traffic on port 80 that include HTTP. The third one is the video traffic on port 4000, and finally the voice over IP on port 5000. And the slide after will show the quality of service classes. The quality of service classes categorized to 3 parts: high priority traffic that include both video and voice traffic, medium priority traffic that handles best effort traffic, and the low priority traffic that has background traffic. Regarding the network evaluation, in this and upcoming slides, I will discuss the performance indicators. First, to measure the performance of the network, we need to compare the performance indicators such as end-to-end delay, throughput, and packet loss. Second, the results of the performance indicators has been collected from the simulation runtime and duration of 10 seconds. Third, all the results in the next slides done with respect of quality of service and non-quality of service scenarios. Finally, the traffic monitored is between the client and server using 4 services. This slide shows the non-quality of service performance indicators. First, the end-to-end delay graph shows that the points are running at the same time because MAC treats all the packets equally. So the packets are sent one by one and the result produced is more than the channel capacity that make the packet dropped. Then throughput, all the services have the same opportunity to get access to the channel. It gives higher priority for background and best effort traffic and lower priority for video and voice. Finally, the graph below shows the packet loss of the four services and showing that video and voice have visual packet loss in their traffic flow. On the other hand, quality of service performance indicators are much organized since quality of service have higher priority for voice and video traffic since they are sensitive to packet loss and need to deliver as fast as possible. So the end-to-end delay graph shows that video and voice have much lower delay because they have higher priority than background and best effort. And the throughput graph also shows that video and voice have the advantage over the lower priority services and that cause flow throughput for both voice and video since they need quality of service to reach their destination normally. Finally, the packet loss graph shows that the packet loss of the video and voice decreased to at least zero because quality of service assigned the priority to be higher for video and voice and decreased the priority for background and best effort. And the upcoming slide shows the comparison clearly. Moving to result discussion, these two pictures indicate the end-to-end delay comparison for both quality of service and non-quality of service scenarios. While using quality of service, the traffic delay increases for both background and best effort because quality of service assign higher priority for voice over IP and video to reach the channel, and lower priority gave to background and best effort traffic since their traffic can wait until higher priority traffic stops. Following the result discussion, these two pictures indicate the throughput comparison for both quality of service and non-quality of service scenarios. These two pictures clearly shows how quality of service treats voice and video traffic, and if they stop sending their information, the throughput goes for lower priority traffic, such as background and best effort traffic. The last picture of result discussion shows the packet loss while using quality of service and non-quality of service scenarios, and that shows how quality of service manage the traffic between client and server with minimum packet loss possible for voice and video traffic since they are sensitive to packet loss, and how quality of service affect the network positively. As a conclusion, I have summarized the process that I have made to meet MobiServe demands. First, I have provided MobiServe with designed and planned indoor network including access point allocation. Second, I have discussed the indoor network topology in detail. Third, I implement and simulate network using Omnet++ platform. Fourth, I have run the simulation using quality of service and non-quality of service scenarios. Then I discussed the traffic design and how quality of service improve the traffic. And finally, I have compared the performance indicators such as end-to-end delay, throughput, and packet loss with respect of quality of service and non-quality of service scenarios. My future recommendation to evaluate the network is to installing more access points with multiple frequencies, improve the network by adding MU-MIMO technology such as 8x8, enhancing bandwidth of IEEE 802.11ax with more bandwidth, add more access points with respect to interference, configure quality of service in all parts of the network to decide the priority for each element in the network traffic, apply band pairing to combine two frequencies together, implement the network in outdoor environment to support future development. I sincerely appreciate your interest in my presentation. If there is any question, feel free to ask me. Thank you very much.